Sometimes you call Ryugu a dumpling. And obviously its comet, 67P, is its rubber ducky. There's a dog bone out in the asteroid belt because asteroids have such bizarre shapes. We can look at the topographic highs and lows and try to understand, can that interior actually support it? And therefore, how strong is the interior? So there's fractured monoliths, which is where the asteroid just kind of has big cracks inside, but there's big rocks sitting together. And the other type are rubble piles, which you can really just think of as bags of a bunch of different rocks loosely held together by gravity. Asteroids with a more intact interior are able to support large variations in topography and thus higher slopes compared to asteroids that have, such as rubble piles. By comparing the slopes of different asteroids, we can hopefully try to understand more about their interior structure. And if the spin interior changes rapidly, you can rapidly change the surface topography and change the surface slopes, which can modify the geology. You'd expect Ben and Ryugu to have more landslide features. Because Itokawa is denser than Ben and Ryugu, it can be spun up so it can start spinning super fast and not have these kind of mass landslides as much as Ben and Ryugu. The work I've been doing on looking at the surface slopes, changes in spin period, it really hopefully informs what asteroids we can decide to visit in the future. It can help point, what asteroid might be more interesting to study for different reasons. And the other exciting thing is it could just allow us to understand the larger population. So there's hundreds of thousands of asteroids out there, and we're never going to be able to visit them all. But if we can just understand that little bit more from the Earth, it can help us understand asteroids as a whole, how they behave, how they interact.